Hello, hello, here we are. This is the very last lesson of this module. Hallelujah, we're almost finished. All right, so we're going to get into lesson 6.7 and 6.5 we were comparing linear functions. 6.6 we were transforming linear functions, and now we're going to go ahead and write linear functions. And to be completely honest, I really think that this is the easiest lesson out of the entire module. So hopefully you guys have a much easier time with this, and hopefully you won't have to ask as many questions as you have been in the past. So again, as usual, please make sure that you guys are taking notes. So you should have your textbook in front of you. You should be writing everything down, everything that I say. And again, just have your notebook just in case you have to write any additional notes. But we're going to go ahead and start with lesson 6.7 on page 201. So let's get right into that. And so you guys can see here, all right, that we are 6.7, and our essential question for this lesson says, how can you represent a function symbolically from a graph, verbal description, or table of values? Okay, so it says here, using slope to write a linear function. It says the information needed to write the equation of a linear function can be provided in different ways, including presented as a graph, given as a description of a relationship, or as input-output pairs. So if you know the slope and the y-intercept of a linear function, you can find the equation representing the function. All right, so first and foremost, the one thing you need to know more than anything is slope-intercept form, which is given to you right here. Now remember that we have said already in the past that f of x is the exact same thing as having y. So this f of x equals mx plus b is the same thing that we've been doing of having y equals mx plus b. All right, so this very first example says to write an equation for the linear function of f of x whose graph has a slope of 3 and a y-intercept of -1. All you're going to be doing here is substituting these values into your m and your b. That's all you're doing. So it says a linear function has the form f of x equals mx plus b, where m is the slope and b is the y-intercept. So that's all you're doing. You're substituting 3 for m and -1 for b. In this case, whenever you do have a negative intercept, just make sure that you are going and simplifying this so that you do not have a plus negative, that you're just rewriting it as minus. All right, so over here, that's all you're doing. Your answer is just f of x equals 3x minus 1. How easy was that? All right, so let's go into that reflect question. It says, how can you use the equation of f of x equals 3x minus 1 to find more ordered pairs that are part of the function? So stop for a second and think about, what is that asking you? Okay, back in one of the previous modules that we've done in class, when we first started talking about functions, we were trying to figure out when an ordered pair was part of the line, or if it wasn't part of the line, and all we did was substitute values of an ordered pair into the x and y values of the equation. And we solved it. We used order of operations to find out if that gave us a true statement or not. And so we can go ahead and use that information to basically find out if we have an ordered pair that is part of this function. So what you can do is apply that same concept to this. Substitute a value for x, solve for f of x, which again, this is the same as having y, so don't confuse yourself. Okay, so substitute values of x and solve for y. Substitute x values and solve for y. Now, let's go ahead and let's solve another point. Let's go ahead and let's just try and find f of 0. Okay, so when x is 0, what do we have? Okay, 3 times 0 is 0, and 0 minus 1 is -1. And so when f of 0, we have -1. So another ordered pair that is on this point is 0, -1. Okay, and if you substituted 1 into here, then you have 3 times 1 minus 1, and 3 times 1 is 3. 3 minus 1 is 2. So f of 1 equals 2, which means that another ordered pair for this line, is 1, comma 2. And that's basically that, okay? So let's go ahead and do a couple of the your turn questions. All right, so I'm zooming you in a little bit so you can see a little bit better. And so it's telling us for this for number 2 right here, it says that we have a slope of 4 and a y-intercept of -2. However, let's go back into these directions. Notice that it's asking you to write a linear function f of x. So you're not just going to write y equals mx plus b. We're going to start with f of x equals, and so we have mx plus b. Our m is our slope, and so here we have a slope of 4 and an intercept of -2. It's that easy. All right, let's do number 4 together. So again, we're going to start off with f of x. Our slope is 6, so we're going to substitute 6 into m. We have x, and then we have plus b. Our intercept here is 0, and I'm not going to put plus 0 because when I simplify that, my 0 goes away. So I'm going to leave this as f of x equals 6x. All right, so what happens when you have a slope of 0? I'm going to leave number 3 for you guys to do on your own, and I'm going to do this harder one with you. But what happens when you have a slope of 0? What kind of line is that? So you guys should be pausing and thinking about this. All right, so 0 is the same as horizontal. All right, so this is a horizontal line. And so in this one, we're going to have f of x. We have a slope of 0, so I'm not going to write 0x because 0 times x is just 0. And so I'm just going to write 0x. Or sorry, I'm going to just write f of x. And so I have an intercept of 6. All right, so pretty self-explanatory. Let's flip on over to the very next page, which is page 202. All right, and let's go into this example right here. You'll see that I've already made a couple of little annotations on here. So it says, the table shows several ordered pairs for the linear function f of x. It says to write an equation for f of x. So now they're not giving you your slope and your intercept. You need to find that on your own. So what we're going to do here is, you see that they have a table for us to look at, and so we have a couple of ordered pairs. I'm going to use any 2 ordered pairs that I want from here. So you can use -1, 5 with 3, -3, or you can do -1, 5 with 7, -7. It really doesn't matter which ones you choose, but you just have to choose 2 of those points and then use your slope formula, which is your change in y over change in x. I showed this here to you now so that you guys can get used to seeing this triangle. This triangle is the symbol delta, and what that triangle represents is the change in. So this is the change in y over the change in x, because rise over run can sometimes be confusing, especially when you have a slope that's negative. Okay, so what you're going to do is calculate your slope using any 2 ordered pairs as I mentioned. So your textbook chose -1 and +5 with +3, -3. And so all they did here was they substituted into the slope formula. And so they did -3 minus 5, so -3 minus 5 divided by +3 minus -1. Remember that this minus negative turns into a plus, and so you really have 3 plus 1, and that's how they get 4. And so -3 minus 5 gives you -8. Remember to always, always simplify, okay? So put a star on that. And so -8 divided by 4 gives you -2. So you have a slope of -2 for this line. But we're still not done because they're asking us to write an equation. They're not just asking us for the slope. So in order for us to write an equation, we still need to find our intercept. Okay, so over here they said to find the value of b using the fact that m, which is our slope, is -2, and that f of -1 equals 5. What they did here is they wrote f of x equals -2x plus b. What we're going to do is we're going to substitute one of these points, because we know that these points are part of this line. We're going to substitute one of those points into the equation and solve for b, because we don't know what b is. And this is probably one of the easier methods of doing it. Okay, so we have f of x is the same as y. Once again, don't forget that, okay? F of x is the same as y. So y equals 5, because like we said, we're using that point that we had in the beginning of that table. So 5 equals -2, which is our slope, times one of our x values, which was -1, plus b. So we don't know what b is, so we're going to leave it there. We're going to solve for that. So when we evaluate -2 times -1, we get +2. So now we're left with this one-step equation. You subtract -2 from both sides, so 5 minus 2 gives you 3. And so your b, or your y-intercept, is +3. So we know our slope was -2 that we solved up here. We now know that our y-intercept is +3. We can now substitute those values into y equals mx plus b. And that's how we got that equation. Okay, so we can check that that equation is correct. How? Okay, so stop for a second. Think about, how can you double check that we have the correct equation? So I mentioned before that you can use a point to substitute into an equation to solve to see if that is a true statement or not. So I'm going to go ahead and I'm going to use this bottom point, 7 and -11, and I'm going to substitute it into this new equation that we just wrote. All right, so we have an equation of f of x equals -2x plus 3. And I said that the point I'm going to use is 7 and -11. Okay, so using that point, I can now substitute 7 for x and -11 for y. So I'm going to do -11 here, and then -2 times 7 plus 3. Okay, I'm going to evaluate now. So I have -11 because that's not changing. -2 times 7 gives me -14. And so now I bring down my 3, and -14 plus 3 gives me -11. And -11 does in fact equal -11, so that I now know that my original equation that I came up with is true. Okay? So what you would write down here for your reflect question is you can substitute a point and solve to see if it's a true statement. So you can substitute, and write this down, guys. I know a lot of you hate writing it down, but you better be writing it. So you can substitute a point into the equation and solve to make sure that it is true, that you get a true statement. Alright, so that's right there what you should be doing. Alright, so I'm going to go ahead and we're going to do number 7 together, but you guys are going to do number 8 on your own. Alright, so let's go ahead and I'm going to erase this here. Okay, and let me come back to this for a second. So I'm going to use the point -1, -4, and then +1 and 6. So I'm going to write that over here. I have -1, -4. Sorry, I'm off the screen over here. All right, and then I have another point of 1, 6. So using my slope formula, I'm going to find my change in y over my change in x. So my y's are changing. I have 6 minus -4 divided by 1 minus -1. So 6 minus -4, remember this turns into a plus, and so does this bottom one. So I have 6 plus 4 is 10, and 1 plus 1 is 2. Always, always, always simplify your fraction. So 10 divided by 2 gives me 5. So I know that I have a slope of 5. Now I'm going to use my y equals mx plus b, and I'm going to now solve for b. So I know that my slope was 5, and I'm going to choose the last point on that table that they gave us of 316, and we're now going to substitute that into the equation. Okay, so this is what we have so far. So this is my y equals mx plus b. My m is slope. This is y. So I'm going to substitute 16. I know my slope. My x is 3. My b, I don't know what it is yet. So I'm going to start evaluating. So 5 times 3 is 15 plus b. So I need to subtract 15 from both sides. And 16 minus 15 gives me 1. And now I know that my b is 1. So my equation for this line is going to be f of x equals my slope of 5. So I have 5x plus 1 because that's my b. Okay, so again, this is y equals mx plus b. Okay, and so it's in slope-intercept form, and we're good. That's all you have to do. Okay, so go ahead, and I want you guys to pause the video, take a minute to do the same thing for example number 8 in the your turn question. So choose 2 points, any 2 points you want. Okay, you can choose the first 2, you can choose the last 2, you can choose any combination. Choose 2 points, find your slope, then substitute your slope and choose another point into your y equals mx plus b and solve for b. Okay, so now let's go on to page 203, okay, which is the real world question. Now this one I'm not going to go too much in depth with it because it's still doing the exact same thing. You're just given a real world example, as you can see here. And so it says writing a linear function from a graph requires the same information and steps as writing a linear function from a table of values. The difference is that the ordered pairs must be determined from the graph. The ordered pairs may or may not be explicitly labeled. What that means is that sometimes they're going to actually label what the points are, and other times if you flip over on to page 204 in the guided practice, sometimes like this graph right here, they don't have the points labeled for you, so you'd have to choose any 2 points, but you're going to have to figure out what those ordered pairs are. So I'll tell you right now, when you guys go to do this one, I would choose this point right here, which is 0, 3, and then any other point. So this is a good one right here because it's perfectly crossing in the boxes of the grid. So this point here is 1, 2, -1. Okay, so I've basically helped you guys out there a ton so that you're not guessing what points to use. Okay, so coming back to this one, it's telling us in example number 3, it says the graph below shows the increase in pressure measured in pounds per square inch as a scuba diver descends from a depth of 10 feet to a depth of 30 feet. Pressure is a linear function of depth. At the water surface, the pressure on the diver is a result of the pressure of the air in the atmosphere. What is the pressure on the diver at the water surface? So you need to first interpret the question. So it's telling you to let P of D, again, don't let this fool you. P of D is again going to be the same as Y. Okay, let that represent the pressure in pounds per square inch on the diver at a depth of D feet. So your D right here, this is going to be the same as X. Okay? At the water surface, D equals 0. If the graph below is extended to meet the vertical axis, the value P of 0 would represent the pressure on the diver at the water surface. So your second step, and I apologize for any sound right now because the janitors are coming in to clean, so I apologize, by the way. All right, so coming back into this, our second step is we need to find out what our slope is. So you need to look at your graph here and you need to see what your points are. So right here we see that we have a point of 10 and 19.1. And then we have another point over here of 30 and 28.0. So again, I crossed out this rise over run. You want to use your slope formula to find out the change in y over the change in x. So we're going to find out by doing 28 minus 19.1, you see right here, okay? And then 30 minus 10. So all you're doing is doing this y value minus this y value and putting that over 30 minus 10. Okay, your book did it a little bit, you know, they changed it up a little bit on you here, but it's just looking like this, and I don't want you guys to get confused. P of 30, okay, the function of 30 is 28. So that's all they're doing here. So you're doing your change in y over your change in x. So 28.0 minus 19.1 is 8.9, and then 30 minus 10 is 20. So that's what they did there. Now, in this particular case, since you're dealing with a real world type question, sometimes there's not a way around it, and you're going to have a slope that is a decimal. And I know that I emphasize so much in class not to put your slope in decimal form, but in a case like this, you're going to have to put it in decimal form. Okay, so they found the slope, and now they just did the exact same thing that we finished doing before, and they substituted that into the y equals mx plus b. They substituted into that slope-intercept formula, and then they used the 0.10 and 19.1 to find for b. And so this symbol right here means approximately, because they rounded when they solved for b, and so they just rounded it to the nearest tenth, and so that's all they've done there. So again, they're doing the same steps. It just looks a little bit more confusing maybe because the numbers are a little different because you've got decimals going on here. All right? Anyways, with that being said, I know that this video was pretty long, and I apologize. It is a very, very easy lesson overall. So just make sure that you guys are doing this your turn question, and that you are going on to page 204 and answering these 4 questions on the guided practice. All right, so again, as usual, I hope you guys enjoyed the video, and by enjoy, I mean understand. I know most of you are not going home and loving all of this, but hopefully these videos are helping you guys out, and you're able to use them to reflect on it, ask any more questions, and if you're not understanding something, please feel free to rewind and go back to something, or write down a question and ask me in class, or go ahead and feel free to send me an email. Alright, so enough babbling. I'm sorry the video is pretty long, so I hope you guys understood it, and I will see you guys in class. Have a wonderful rest of your weekend.